Hello everybody and welcome back to Maths Miss Buick. We're still focusing on equality of complex numbers and we're faced with this question here. Express z, which is equal to the square root of 3 plus 4i in the form of a plus or minus bi. So let's begin by rewriting our question. So the square root of 3 plus 4i, and we're going to equal it to a plus bi because we know it's of the form of a complex number, which is a plus bi. Now, to normally get rid of a square root, we would always square both sides. So what you do to one side, you do to the other. And we have now 3 plus 4i is equal to a plus bi by another a plus bi. So we're going to square that out. So a by a is a squared. A by bi is abi. bi by a is another abi. And then bi by bi is b squared, I squared. We know that I squared is a negative 1, so we can replace this as minus b squared. And we're going to add our two ABIs here in the centre as well. So we have a squared plus 2abi minus b squared. We can see now that we have a question or equation that is of real parts and an imaginary parts. So let's highlight the real in red. They're all real, so real is on the red side. And then let's highlight the imaginaries in the blues. Now, let's form two equations, one real and one imaginary. So we'll form the real over here and we'll form the imaginary equation over here. We have 3 is equal to a squared minus b squared is our real equation. And our imaginary is 4 is equal to 2ab. So here is our real equation and here is our imaginary equation. Now let's take our imaginary equation and we'll solve it to get either a on its own or b on its own. So let's, for the sake of it, get b on its own. So 2a is being multiplied by the b. So we do the opposite to that, which is division. So now we have 4 divided by 2a equals b. And let's divide on the top and the bottom by 2. So we have 2 over a is equal to b. Now we're going to take our 2 divided by a equals b and sub it in to this b up here. So we have 3 is equal to a squared minus 2 over a to b squared. And you can see now that we have an equation all in terms of a. So we'll square out this bracket first of all. So we have 3 is equal to a squared minus, well, 2 squared is 4 and a to b squared is a squared. Now we're going to multiply across by a squared. So we're going to have 3a squared is equal to a to the power of 4 minus 4. So we multiply there across by a squared. So let's now get this equation by, we'll simplify it down by putting the highest power first. So we have a to the power of 4, we'll bring over our 3a squared across, and when we do that it goes to a negative 3a squared minus 4 equals 0. So let's open up two brackets now and solve. So how do we get a squared? Or a to the power 4, should I say? Well, a to the power 4 can be done by a squared by a squared. And two numbers that multiply to give negative 4 that add to give negative 3. Well, negative 4 plus 1. Now we'll equal both of our brackets to 0. And we'll solve to get a value for the a. So you can see here that this is difference of two squares. We've got a square here, and a negative in between. So we can do a and an a plus 2 and a negative 2. And we can see that when we equal both brackets to 0, a is negative 2 and a is equal to positive 2. Now let's look at this one over here as well. So we'll bring that down over here. And if we bring or positive 1 across, we get negative 1. And if we square both sides, we get square root of negative 1, which of course a is equal to I. However, that is incorrect because a is the first part of our complex number, just to remind you again. And a is always real. So this I is not a real number, it's in fact imaginary. So we can discard this a is equal to I, and we have our answers here for a. A is negative 2 and a is also positive 2. So now to find values for, well, there are a's. Now to find values for our b's. Well, we know from the first part of the question that we had 2 over a is equal to b. So let's put in the values for a. So let's start off with our negative 2. So let a equal negative 2. So we have 2 over negative 2, which of course is negative 1, so that's b. And then our other one, let's go over here with it, let's rub this out. Let a equal positive 2. So we have 2 over 2, which is equal to 1, so b is 1. So to finish off the question, we're going to write them in complex number format. So the first complex number is our negative 2, which is our a. So we have negative 2. And we had the negative 2 in here. So we have minus I is the first complex number. So minus 1i if you want. And then the second one was a was positive 2. And our b was also positive 1, so plus 1i. So our overall answers are minus 2 minus 1i and positive 2 plus I.